All right, we are going to go ahead and add some more fractions today. We'll start with a little bit more basic, but harder than yesterday's. So we've got 3 over 2x minus 1 over 8x squared. So we need a common denominator. So we first look at the numbers 2 and 8. What would our common denominator be? 8. The common denominator would be 8. Okay. Now, if we look at x and x squared, we have to go with the highest power. So which one's the higher power? X squared. Okay. So this one's the same. So we don't have to change the top at all. So it's just 1. What do we have to do to 2x to get 8x squared?
4x.
Times 4x. Very good. So we get 12x. So if we put them together, we get 12x minus 1 over 8x squared. Remember, we have a binomial. Let's put it in parentheses so we realize that's one factor, because otherwise we can try and divide there and we cannot do that. Okay. Now let's get into the much more involved. All right, so we have a minus 3 over a squared minus 2a minus a minus 4 over a squared minus 4. These top two do not have a square, so I want to put parentheses around them. Now let's look at the bottom two. Is there anything common in these two parts? A. So if we took out a, we get a minus 2. So I'm going to rewrite that side. So we have a minus 3 over a times a minus 2. And a minus 4. Could we factor that? We have the difference of 2 squares. So a minus 2, a plus 2. Okay. So last week when we were doing multiply and dividing, we just started canceling. That's not what we want to do. We have to get the common denominator. This is where they're a little bit more difficult. Every single factor has to be in our common denominator. So our common denominator, we need an a. We also need an a minus 2, and we need an a plus 2. So here's a factor, here's a factor, here's a factor. We don't have to list it twice unless it's twice under the same fraction. Okay. So if this said a minus 2, then we would need a minus 2, a minus 2. But since it's plus 2, we need an a plus 2 and an a minus 2. And we need the a, so we don't have to list it twice. All right, so this first one, what does it need in order to look like this? So we have a, and we have a minus 2. What else does it need? A plus 2. So we're going to multiply there. What does this need in order to look like this one?
Okay.
We have a minus 2, we have a plus 2, so we need a. So we have to times by a, and I'm going to put it here with that negative to make it a little bit simple. So I'm going to rewrite this. And over here we have negative a minus 4. So now we're going to have to multiply. So we need to FOIL a times a gets us a squared. I'm going to rewrite it over here. A squared. We get negative 3a plus 2a. And then negative 6. Okay, so that's all over a minus 2, a plus 2. I'll erase that line. For the second one, we're going to distribute. Negative a times a gets us negative a squared. Negative a times negative 4 plus 4a. Almost lost a. We still have our denominator. All right. So these denominators are the same, so we can go ahead and start combining like terms. So we got one denominator. We have a squared minus a squared. What does that give us? It cancels out. All right, we have negative 3a, positive 2a, which is negative a, negative 1a, and positive 4a. What is that? 3a minus 6. So the two parts, we can go ahead and put parentheses around. Is there anything common in those two? 3. If we took out a 3, we would get a minus 2. The reason we did that, now look at the bottom. And the reason we left those in parentheses is because then we can cancel. We're left with 3 and a plus 2. So we took two much larger fractions, and we made it a much simpler answer, didn't we? I'm not gonna lie, these are work. So my plan is we're gonna work on these for a couple days, this specific addition, subtraction with the harder denominators. So we're comfortable and ready to go on with this. All right, so do another one like that. So this one, we have x over x plus y, parentheses, y over y minus y. These are completely different factors, yes? So we need both of them for our denominator. So what does this one need in order to look like this? So we have x plus y, so we need x minus y. This one has x minus y, so we need x plus y. No, because what you're thinking is, going back to yesterday, if we had this, x minus 2 and 2 minus x. So they were the same, they both had a negative. But this one of them's a plus, one of them's a minus, so we cannot do it that way.
Oh.
So if they're opposite signs, you have to use both. Okay. We'll try and do one like you're talking about in a second. So we distribute, we get x squared minus xy plus y squared. Now, same denominator, so we can combine like terms. I didn't leave much space, but we get x squared. Now let's look at negative xy, positive xy. Cancels out, and that's perfect. Plus y squared. Now, let's think about this. X squared plus y squared. I didn't know that on the computer. Okay. Come over here. X squared plus y squared. We have squares, but is it a difference of squares? Since it's a sum or addition, we cannot factor it anymore. So this would actually be our answer. If it was minus, we could have made it x plus y, x minus y, but it's not. It's plus. So you stop right there. Okay. So I'm trying to find one more. Let's see this. So we have on this one is 3a over a minus 2b plus 6b over 2b minus a. So this is one where we have the same numbers and both of them are subtract, but they've been flipped. So what we're saying is, can't we just turn this one around? Which we can. When we turn it around, we bring that negative out in front. So I want to rewrite it. So now we're going to bring this minus up here. Minus 6b, a minus 2b. So let's look at our denominators. They are the same. Yes. That's perfect. So that makes it even easier. We don't have to find the common denominator. We've already switched it around to find it. So on the top, we have 3a minus 6b. Anything common in the top? 3. So we get a minus 2b. A minus 2b. A minus 2b's are the same, so we're going to cancel them. We're left with 3. And that's perfect. So that's what, remember, if they are the same two parts, so whether it's a variable and a constant term or two variables, and both of them are minus, you can switch it around and bring that negative out in front. Okay. So what I want to do today, so 268 we are going 35 to 53 odd. 35 to 53 odd on 268.